Okay, so we're gonna talk about a lot of things, um, and I need you to take your notes out, put your computer away, put your cell phone away, and those we got a lot of things to talk about. First of all, we're gonna go through the whole chapter worth of stuff. This period is gonna have extra day to finish that first part of homework. You got till Monday to finish that part. It's very difficult. You have till Monday. But it's only first page, not 4 pages. Only first page. 10 questions. Each question has multiple parts. They are very difficult. They are not easy. Even Kevin is struggling in second period. Katie is struggling in the second period. Other people are struggling. Yes, they are not easy. But the way to think about this is this. Um, One of my I don't know if you've seen this guy. His name is Terrence Tall. He showed up on Facebook as a master class. He's a truly genius. And at 10 year old, they went to take him to get tested for gifted. His mom is a math teacher, so they went to pick him up. On the way, the guy is picking him up. He was reading calculus book by himself, and he actually figured out how to do all the calculus problems. He knew how to do simple derivative. He know what's derivative mean. He knows how to do that at 10 years old. But he says one thing very profounding. I was watching his master class because I'm always gonna try to better my craft of doing things. So even though I teach in the subject for a long time, I still wanted to be a better teacher. So he says one thing very, very interesting. Pay attention. He says the problem is never about right or wrong. It's about what you learn from it. So today you got it wrong. That's so perfectly fine. What did you learn from that problem? Are you gonna get better next time? Not just only on a certain perspective. You have a very, very profound thing to say. Even though his level is way up there, I can barely understand his lecture. Actually, I'm gonna be first to admit I don't understand his lecture. He teaches in the UCLA. The guy in the Putnam Square test, which is the hardest math exam, each question is worth 9 points. All the brightest mathematician when to take that test only get an average of 1 out of 54. 1 point out of 54, average score. The guy can score a 52 points or perfect sometimes. The guy is so phenomenal. But he really think about how to think. So I really appreciate what he said. So let's start with what we know and what can we learn from it. Yes. Oh. All right. So first thing we're gonna talk about area, and areas is gonna be here. So and it's gonna be a long lecture. It's gonna be very, very, very tough to stay through while trying to keep it entertained. Area between the curve. So let's start first talking about area first. The area between the curve, and then we're gonna go into value. So first of all, area between the curve is gonna be fairly easy, but there is a lot of stuff to be learned here because once you learn here correctly, when you go into other things, it will be easier. So here's what I'm gonna draw the first graph. The first graph is gonna give you like this. So I'm gonna do it here. Okay, so the first graph is gonna give you the top part of the graph is gonna be like this. So we're gonna call this f of x. And the bottom graph is gonna be like this. And we're gonna call this g of x. And then we're gonna cut off between a and b. So I can have a and b here. And then we have this shaded region, and we're gonna shade this region as black. So sorry, we're gonna cut off A and B here, and we're gonna shade the region right in the middle, the black part. Now, some people already watched this lecture, like Bristol, other people's. I appreciate you because it will make it a lot easier for you to understand, and you should try to do those problems. So this is the region I'm caring about, the shaded region. Now, what people had to think about is this: is fundamentally speaking, in order to get area of this region, it's not that difficult. It's very intuitive, and people just have to see it. So I'm gonna copy this. So I'm gonna copy this. I'm gonna copy, and I'm gonna paste. So I don't have to redraw the graph. Okay. So what happened is I'm gonna erase this middle part of it, and what happened is I'm gonna calculate the area of the red. I'm gonna get this area here, and how do I do that? I'm gonna go all the way down. Sorry, that was a very bad sketch. But this is my first goal. The second goal is I'm gonna erase this part. I'm gonna say, hey, let's find out this blue area, that's something I can find through this. So we're gonna do here. And we're gonna find this blue area. But if I have red subtract blue, and is equal to the black. So red subtract blue is equal to black. So in the way to think about it is this, as integration of f of x and minus integration of the g of x dx, and that becomes the equal to area under the curve. Oh, area between the curves, sorry. In general, it's gonna be equal to, another way to think about it, I think is for easiest student to understand, is a top minus bottom. Top minus the bottom. I try to color code so you can see everything. And you're gonna be like, yeah, that's very intuitive. I understand that. And trust me, why do those kids struggle? Because they still have problem understanding those stuff. And so that's it. Area between the curve. Now you're gonna be like, oh, okay, well, so now you're gonna say it's A and B matter. Yes, there was two type of question can occur. One is A and B is giving, so it will create this bounded graph. But if A and B is not provided, sometimes you had to find this point, which is you had to set two equations equal to each other and solve for it. So sometimes, which majority of the time, so majority of the time A and B, so if A and B bound is not provided, then you have to find intersection between the curve. Have to find intersection between the curve. Between two graph functions. That's better. And the way to do that is set this equation equal to each other. And always solve with 0. Why? Because that's important. F of x equal to g of x minus g of x. And that's equal to 0. And factor and solve. So you're going to factor and solve the situations. So not all the time A and B is provided though. Not all the time A and B is provided. So in this case, if the A and B is not provided, so the A bound and B bound is not provided restriction, then you have to find the intersection, because between the curve, you have to find the ending of that part. Okay, so this part that sometimes you have to find this intersection, and that's the things that we're talking about. But sometimes very beginning question usually provide a bound and B bound, then you can actually says integration from A to B. Oh, I forgot to write that part. A to B. top to bottom. Sometimes you have multiple intersections. Sometimes you have 3 intersections. Now the curve is going to switch. Okay, the top function becomes a bottom function becomes a top function. So it's very, very, very important you understand which one's on the top. And those are kind of things that you need to emphasize on. Now, one more thing you have to understand is a lot of people don't, if graph is underneath here, let's just say if I have something that says, so this is a one thing I just realized this year, have some students have this problem. That just says if I have this here, and I have this here, and between A and B, and this here, now this is a tricky question. A lot of time people thought this area between the curve is negative. Do you think it's negative or positive?
Positive.
Right, area should be positive, right? The area between the curve. But how does that make sense? It's below x-axis. Yes.
Negative minus negative is positive.
True, but negative minus a more negative, right? So for example, just to look at a number here. If you have a -2, right? If you have a -2 here, that's the top functions, right? Minus -4. And if I just do a dx here, is between, let's say between 0 to 5 in this case. This is the top, this is the bottom. So this is between 0 to 5 and -2 plus 4, so it's 2 dx. So that is going to be something that you have to understand. That's what is a positive, because 0 to 5 in this case is going to give you 10. So it's still positive, even though it's below x-axis. But if you keep consistency, top minus bottom, in this case, the top function is actually the red functions here, and then you gotta understand that. So those are things small thing I didn't realize as I was teaching, and I find out those mistakes here, and a lot of students misunderstand. So that's great. So what we're gonna do is going to start a question, and I give you a minute a head start, and I want you to find those areas, and we're gonna talk about as much as I can. So I didn't really issue too much homework questions here, but I didn't actually get a chance to issue a question because I want to get to the volume first. But if you understand area a little bit, then you can get to volume would be no problem. But since I'm trying to teach all in 1 week, they really screw up the schedule. So I need to figure out a way to best help you. So I'm going to start with simple things. So I'm going to ask you to do them. So if y, we're going to ask you to graph this. So y equal to x squared plus 2. Y equal to x squared plus 2. Y equal to negative x. And then x equal to 0. And x equal to 1. So you guys need to learn how to graph it first. If you learn how to graph it, then you're better off. Learning how to graph. So learning graph y equal to x squared plus 2, y equal to negative x equal to 0, x equal to 1. I want to find the area between this bounded graph. But you have to graph it correctly. And once you know how to graph, if for sure your graph's right, then you can go on to evaluate this area between the curve. We never teach you, but only one extra step, minus the bottom. We usually just integration the top. With a certain boundary, this one's actually easy. So I'll give you 1 minute, see how far you can get to, then we're going to get to the head start. I just grabbed this one. I also gonna grab the other one. And I'm gonna cut off here. And then now I'm gonna shade it. It's basically each slice, you're just gonna add up from left to right. So now you should have your integral set up like this. Between 0 to 1. Between 0 to 1. And the top minus bottom. And if you see that that's negative x here, then that's why it's make it positive. So it's going to be between 0 to 1, x squared plus 2 plus x dx. Do you guys have a correct setup?
Yeah.
Good. X3 over 3 plus 2x plus x squared over 2 between 1 to 0. And if you do that, it'd be 1 over 3 plus 2 plus 1/2. And that should equal to 17 over 6. Next question. Remember, this question is going to be the one that you had to find the boundaries. So between two intersect graphs. So here this will probably an example of intersect graph. So we're going to say f of x is equal to 2 minus x squared and g of x equal to x. And we're going to ask you if you know how to graph this. And then also find their intersection. I kind of told you, set f of x equal to g of x, and then move the function to one side, factor solve. Remember, don't ever divide by both side value, and we're going to talk about the next question, which is some people does that. It's drive me crazy. Abby, do you have a problem? Good.
What did you go from the third line to the fourth line? Like, what did you plug in?
I plug in 1 and then subtract 0. So supposedly that you will have, I plug in 1 into here, and then I subtract, plug in 0, so it'll be 0 plus 0 plus 0. So nothing is there. So 17 over 6. Did that answer your question?
Yeah.
So we're going to give you a brand new question. This one, I'm going to remind you. You have to find the boundary first. And once you find a boundary and you evaluate it, you're going to get a fraction. That fraction, numerator plus denominator, is equal to 11. So if you're going to get a fraction, so that way you know if you did it right or wrong, you can jump ahead before I go over it. Is Sarah Melise here? Okay. You're hiding behind Samuel, so I cannot see you. Here we have a 2 minus x squared. Hopefully you guys know how to graph those. You guys need to know all the simple graph. And g of x equal to x. This one you guys need to know as well. So if you go in, first of all, you need to understand, what does x squared graph look like? It looks like a parabola. Hopefully all you guys should know that. Negative x squared is going to go what?
Down. It's gonna be a hill.
Yep, it's going to be a hill, and the vertex is at 0. So it's going to be like this. Except I think this graph is bad, because I'm going to have to move to a little bit. And then I'm going to go down to 4. And the g of x equal to x is going to be here. Now this one I can graph because I have a nice graphing paper, and I have an app can help me make a line straight. And so I can know my intersection very easily. It's obviously -2 to 1. But most of you guys cannot come up with this graph, which is fine. You don't have a graphing paper. You don't have a nice apps to help you make straight lines. You don't have a grids, graphing grids in the background. And that's perfectly fine. That's why you need to do algebra. You're going to set equation equal to each other. And when you do that, you solve for it. I always make sure my leading coefficient is positive. And then x plus 2 and x minus 1 is equal to 0, x equal to -2, and x equal to 1. So I find out my intersection is at -2, which is kind of makes sense. So -2 to 1 of the top. What is the top? 2 minus x squared, right?
Yeah.
And then minus x dx. Now I'm going to show you a shortcut of this. When you're doing problem like this, there's a shortcut. The shortcut is understand common denominator. And yesterday, like you think like I don't have to learn. Like this is the first year I taught calculus. So this morning I was watching lecture from 2 o'clock in the morning to 4 o'clock this morning. I wake up at 2 o'clock in the morning. I watch a lecture from 2 o'clock to 4 o'clock. I gotta make sure I know what I'm teaching tomorrow. So I was watching over again. This is the third time I watch the same lecture. One of the part in BC calculus is still talk about similar ideas. And this idea is very interesting. Is pay attention to this. It was those was about hyperbolic function, about Shinch and Cash. They trying to combine two power series, and it was very interesting because talk about similar idea. If I integrate this, it's going to be 2x minus x cubed over 3 minus x squared over 2 between 1 and -2. Now this is actually very interesting because you can save you a lot of time if you do it correctly. Minus -2 if you plug in, so it's going to be -4, I think. -2 to the cube is -8, so it's positive 8 over 3, and the minus 2, I believe, and then that's it. But it was about this problem was complex power series, and he used a similar ideas. He says, well, why would you want it to combine these common denominator in here and here, where you can just subtract the same denominator? What I'm trying to say is this, is if you pay attention to detail here, this one is 2 plus, this one's going to be 2 plus 4, so it's equal to 6. And this one's no big deal. This one's integer. Because a lot of time you're going to get all fractions. Then you say, well, is there any easy way to do it? Because you won't want to combine fraction on one side and combine fraction on the other side. So what the next thing is, you're going to go here. What's -1 plus -1 minus 8 over 3? Why is minus? Because this minus sign is going to distribute. So it's going to end up to be 3, minus 3. And then it's going to be minus half plus 2. So it's going to be plus 3 over 2. So this will end up to be 9 over 2. But you never have to get to a fraction of 1 over 6. Because if you do 1 over 3, 1 over 2, that's going to have to get 3 over 6 and 3 over 6 and 2 over 6. And you need to combine that with the integer. That's a lot more work. And this idea using for other things too, and that way you can benefit later. So don't, get struggle with that. Can I go on to the next part? Oleg, you okay? You falling asleep soon? Okay. Your eyes looking more like Chinese.
That's just me in the morning.
Okay. Anyway, so I hear the next question is this one. Now, this is a question that you have a multiple intersections. You have, in this case, I remember at high school, I was not smart, and there's the reason why I would tell you, I'll be the first to admit to you, I wasn't smart as you guys, nearly as smart as you guys. I take Calc 1 at high school at sophomore year, junior year, and I have a really horrible teacher. Like the teacher only gone through the derivative of x squared by end of the year. And I was really upset. And I take a test, I got a 2. And you see the reason why I got a 2, because I didn't even know what integration is. So I decided to go to school with Dr. Phillips, and she is one of the best teachers. So she was so good that every single student got a 5. Every single student had a 5, not only like few. Every single student had a 5. So I go there. I thought like, this is the second time I take calculus. I should be smarter than everybody else. I'm Chinese. I'm inherited smart in math. But lo and behold, I go in there, I take the first test, and I got this question. I got it completely wrong. She gave me negative 20 points. I remember very clearly until this day. She take out 28 points. She take out 20 points. I have my final score on the first algebra test. I got a 58. And this is the second time I take calculus. So I was inherently stupid.
How do you get a negative 28?
I got to subtract 20 points out of this question. So I'm going to show you this question. This question was xq equal to xq graph and x, and they say, hey, can you find the xq equal to x, right? So first thing, let's graph this function. And I will tell you, now I probably lost all the credibility being a teacher because I suck in math. I was stupid in high school. And I always roast myself because I think it's funny. There's a famous saying, they say, those people who can't teach. Have you heard that before? No? Those are people who cannot do things, they become a teacher.
If you can't do it, if you can't teach it, become a teacher.
It's like a very insulting to the teacher, but it's actually true. That make you a better teacher because you know all the mistakes you make. Because smart people will never see those mistakes. They will be like, yeah.
There's a continuation to that saying.
There's continue. What is that?
If you can't do teach, if you can't teach PE.
Teach what?
PE.
Teach PE. Wow, that's even more insult. If you can teach PE or social study. No, I'm just kidding. Just kidding.
Then don't say that.
Just kidding. I'm just kidding. Don't get me canceled here. So it turns out there was two regions here. There was 2 regions, and the top graph and the bottom graph kind of switched throughout the times, and that's an interesting thing. So what happened is you're supposed to find intersection because you don't know how to graph perfectly. And if you graph it perfectly, great. But if you didn't, then you really need to see what happened here. So if I set equation equal to each other, and that was the test question, x cubed equal to x. The genius of me, what I did is I take this, I'll divide both sides by x. I was super smart, right? I thought like this is genius move. X squared equal to 1. And then I will get even smarter. I says, hey, that's square root both sides. And that's at x equal to 1. And that was my answer. That was my answer. And then the teacher, when I got a test paper back, minus 20. I'm like, I went to the teacher and I asked her what's going on. Why didn't I get it right? He's like, well, she says one thing. She says, you don't belong to my class. She didn't even say you get it wrong. I say I should deserve partial credit. She says, if you think you deserve partial credit, you don't belong to my class.
Yes, yeah.
So literally this teacher just roasted me so bad that it just don't belong. And I was go home crying because I was like a little, I don't know. So I can't say that word out loud.
Mr. Ye, are you sure you shouldn't take a role as acting because you did a very good job of pretending to be a drunken sailor there with all the baby seals you
Yeah.
What
Okay. So what I did is, what the teacher did is, teacher actually not only said solve this problem, she said solve this problem 3 different ways. So I really don't deserve any points. Okay, so I did 2 mistakes on the way. So first mistake I did is I divided both sides by x. Those of you guys are smart know that you're not allowed to do that. You cannot divide by both sides by x. That's just not right because you got rid of one answer. Because fundamental theorem says those are 3 answers. So so that you're supposed to do like this, and you're supposed to factor out x minus 1, and then you're supposed equal to factor more. And then x equal to 0, x negative 1, x equal to 1. So there are 3 solutions because fundamental theorem told you those are 3 solutions. Don't worry, I'm not the worst one. I think some people are the worst one. I think some people don't know how to do math inside the cube root both sides. And they got x equal to cube root of x. And they say, what do I do from there? So, and then they say, that's cube both sides, and they cube both sides, they go back x squared equal to x, and they're like, shit, I think I go anywhere. And literally I seen this on the test paper before. I'm like, oh my goodness. Okay, anyway, but that's okay. That's enough roasting of myself or other kids. Poor kid, whoever did that. I apologize. But then you should really know how to do math. So there was 2 regions of here, and there's 2 regions here that you should do top minus bottom. But you should do it here on the left side should be negative 1 to 0. So you can break the 2 sections. And then you can do here between 0 to 1. Now what happened? The top part of the graph and bottom of the graph switch.
Then it's all negative.
So here it's going to be x cubed on the top. And the bottom is actually negative x. But at the other side, the top graph is actually x minus x cubed dx. So on the left side, x cubed is on the top, bottom is negative x. On the right side, x is on the top, x cubed on the bottom. And then you say, okay, well that's that. You get the answer. And some people it's gonna be like, wait, Mr. Ye, is an easy way? There is an easy way. What's the easy way? Yes.
You can flip your interval to the first one from 0 to 1 and negate that inside, and it's equal to the other. They just multiply by 2.
You multiply by 2, and so what do you think the area is gonna be?
Twice.
Good. So you're gonna get twice. So it's 2 times. You can do that between 0 to 1 because they have symmetry. You use the leverage of symmetry. Symmetry is a leverage, right? Not all the questions going to give you symmetry. For God's sake, I won't give you a symmetry problem. But if there's symmetry, then you can do 2 times of that. So 2 times x minus x cubed. So if you do this way, the first way is fine too. You're gonna get same answer. So if you integrate this, it's gonna be x2 minus x4 over 4 between 1 to 0 and between 2, and it's 2 times 1/2 minus 1/4, and that's equal to 2 times 1/4, and that's equal to 1/2. But if you do this separately, you're gonna get 1/2 on each, or 1/4 on each. You're gonna get 1/2 still. So it turns out there was always a shorter way to do problem, because it's if you think about those things that you use, there was always a shorter path to think about, like Sergio was talking about. We still have one more question on areas, and then we're gonna go to values. Okay, so the area, one more question. It turns out sometimes we don't always give you a function in terms of x.
Mr. Ye.
We can give you a function in terms of y.
Mr. Ye.
Samuel, shut up. Thank you. So in terms of y perspective, now y perspective is kind of interesting, because y perspective, you say, well, what do you mean by that? It turns out not all the time you generate graph, you can have to find a different way. So you can say, well, what if I give you a question like this? What if I give you a question that says y squared equal to 3 minus x, and x equal to y plus 1. Now, why this problem is creates such a difficulty? You guys probably never seen y squared graph before. Have you guys ever seen y squared graph before?
Is it just the same thing as the graph of square root of x?
No. Okay, so have you seen YMCA?
Yeah.
YMC, right? So it turns out like this is a YouTube. This is a not YouTube, but parabola, right? X squared, right? Now y squared is basically just gonna go toward the right. Okay.
Wait.
So I'm gonna show you here. This is a y equal to x squared. That's look like this. But what if y squared equal to x? It's going to be sideways. Now, if you square root both sides, that's what the problem is. If you square root both sides, if you say x equal to square root y, x equal to square root y, do you see the problem? No, hold on a second. No, I did it wrong. Y equal to square root x, right? Y equal to square root x. Do you see the problem? You got rid of half part of the graph. And you say that should not be allowed. It should be plus minus square root x. And we're going to talk in detail of this question a little bit more. But what happened is there was this fundamental problem. If you square root both sides, you get 3 minus x, you're going to get half of the parabola, which is the other half parabola does not exist. And then, so you're going to have certain issue here. So there was one way. So I'm going to show you very quickly what this actually happened. So it's probably going to be like 3 and it's going to go like this way, but it's missing the other way. So it's missing the bottom part. So you don't see the graph completed. You don't see the region is included. So that's a big issue. So the best way is, let's look at this in terms of y perspective. Now, in y's perspective, that means you have to solve a function for x. So what I did is I take this, I isolate the x. So x equal to 3 minus y squared. And this one's already isolated, which is nice. So this one becomes f of y. Nobody ever seen this before, f of y. This one's f of y equal to y plus 1. And then you say, okay, let's graph 3 minus y squared. We already know y squared is look like what? It's facing, parabola facing right, right? Now, what's negative y squared?
To the left.
Facing to the left. Now, here's the next tricky question. Are you guys following me so far?
Yeah.
Okay, so you got that, just say this part here, right? And then y squared. Now we got negative y squared. Oops. Okay, that's facing the other side. But what if plus 3? Are they gonna go which direction?
Is it gonna go right to the up, left, right 3,
Make up your damn mind, Jesus.
right 3.
It's going to the right. So RJ says it's going to the right. Let's pay attention. It's going to the right, or going up, or going left, or going right.
I think it's going up.
You think it's going up?
Yeah.
Okay, that's fair.
I think it's going.
And it's okay if you get wrong. Remember, you just learned something from a problem. It's not about right or wrong. Plus 3. Wait, is that what Will say? Oh, no, that's Will's fault. That's not your fault, Abby.
Will.
Yeah, you should have followed RJ. RJ does homework. Well, sort of. Yeah, sort of. 3 minus y squared, so it's gonna be right here. So it's gonna be this way. So it's gonna be like this parabola going like this.
Y plus 1. Up.
And the y plus 1. Now this one's interesting, but you do know how to graph x equal to y, right? You do know how to graph this part, right? Now what does plus 1 do?
Put it up,
To the left.
to the right,
To the up.
to the right,
To which one, Abby?
to the right.
I think to the.
Wait, moves diagonal.
To the right. You're right. It's moving to the right. Good job.
Wait, wouldn't it go down 1? No.
But how? It's plus.
Yeah, it went down 1. No.
No, it went
It
to
went to
the right
one, both.
Well, technically it's not going down, it's going to the right. It's shifting to the right in this case because it's in y perspective, so it's becoming positive.
Yeah.
I have a question.
You sure, I'll answer your question.
I thought it was like the opposite.
It's
Oh no, it's a in this case it's like you think about it's y squared plus 1. That would be easier to think about it. If it's a y squared, it's a parabola sideways, right? It's plus 1 is moving the right unit. Now, if it's a y plus 1 parentheses square, then that's a little bit different.
It is y plus 1 equals x.
So think about this as a y square. If it's a y square, it's facing right, right? And then this plus 1 is going to move right 1 because it's in that perspective. And the way to think about it is you turn your head 90 degrees to the right. You have to know your left and right. So turn it this way. Now, if you go up 1, then it's actually going to the right. Okay, so please don't turn the wrong side because second period from Katie. Katie's like, I told Katie to turn right, and she goes like this. And I'm like, no, Katie. No. You can not be so smart and so stupid at the same time.
History, smart people don't actually.
But if I go
have
up
a-
one,
But that's true. I don't. I mean, I have brain, but I'm dumb. So yeah, you gotta make sure you. Now, here's the thing. Shh. Here's the thing. If you turn your head right? So what is the top graph? If you turn your head to the right, what is the top graph? Is it the red part or the blue part?
Red.
So in this y perspective, right? Y perspective. The y perspective is gonna give you something like this. The y perspective is gonna be integration a to b is right minus left. It's always right minus left and dy. It's right minus left. So then you're gonna work it out. You're gonna say, hey, let's do integration of the right function. In this case, is gonna be 3 minus y squared. And the minus, but make sure you put a parenthesis because you don't have parenthesis is bad. And now it's between which value to which value though? I think this graphs intersect here. Between which boundary? Well, we don't know. Can we set them equal to each other? So let's set them equal to each other. So 3 minus y squared equal to y plus 1. If you solve for it, it's still going to get y squared. Plus y minus 2 equal to 0. So y plus 2 and y minus 1, I think. And the y equal to -2 and y equal to 1. So that's going to be from -2 to 1. And there you go. The answer, I'm not going to do the work. I'm just going to plug in the calculator. I'm going to get exactly 9/2 here. But that's the work I did. But I said two equations equal to each other even in perspective of y. So what do we teach you today? Let's review.
Wait.
Yes.
Right. Oh, yeah. So for the interceptions, right, since y equals -2 and y equals 1, does that mean that the bounds are horizontal?
Yes. It's going from here. That's a good question. It's going from here to here. So it's going from here to here. And the way you calculate area, it's going to be adding each slice from -2 to 1. It's going horizontally. Yes, thank you for pointing that perspective out. So this is a perpendicular to the y-axis. Can I get out of here? Okay, so we only finished the easy part of the lesson.
Are you kidding?
Yes,
No, you're not.
I'm not kidding, but that's okay. You guys are doing great. At least I keep you entertained. I make fun of myself, how stupid I am.
I like when you yell at Samuel.
Huh?
I like when you yell at Samuel.
Good, I'll do that more often. If you keep you awake, that's worth it. And keep Samuel awake while at it. Or Alex.
Don't yell at Will. I was playing with the stapler.
That's a reason to yell.
Did I tell you that there was one kid named Christopher in my class? Christopher was so interesting. He's always stoned. He's stoned so bad. He take a stapler and he just like take this and bam into his hand. And he's like, "Look, Mr. Ye, it doesn't even hurt." I'm like, "Christopher, you need to stop doing drug." And he's like, "No, I don't do drug, man." And then, now what's more interesting is, the stapler that stick in his hand, and the things on the side start turning red. Like, it's like expanding at a rate, It's like a DRDT is... I was like,
Damn, you studied calculus.
I know, right? And I was like, look at this. I was like, no, Christopher, you really need to stop doing drug.
I don't do drugs. I just do the white stuff inside my cabinet.
Probably true. Okay, so that was a really interesting story. But yeah, that was like, he's so smart in math, though. The guy is so smart in math. Yeah. It turns out all the people are...
It turns out to be yours.
Okay, let's talk about the harder part. Oh yeah, what work can we do? So we're gonna relax for a few minutes.
Fun.
Oh, we're gonna look at bun cake. So we're gonna break the internet here so we can have fun away to get in. Okay, so okay, YouTube. Okay, so we're gonna do wood turning, wood twisting, okay.
Aluminum foil.
So this is a very, very relaxing. obviously there's 5 million view of people watching this, so it's probably like pretty cool. So I decided to watch this, and I was truly amazed by this like craftsmanships. Like this guy can just do anything. This would originally look like this, like looks like this, right? And you take this piece of work and you just put it right in the center, and we're gonna call it this line here. That line going through the center, we're gonna call it axis rotation. The axis rotation is gonna be very cool. And so now he's covering our cylinder, right? He just covered our cylinder right here. This part is too big, so he just kind of carve it up and just like keep very consistent hands. And just like now he covers small like things there. He had like a handle, I think. I don't know what is it, but this is so cool though. This is so cool. Now pay attention to axis rotation again. We're folding the cylinder. Now what happened is he decided to change this, and then he put it here, tied it, and then start spinning again, and then look at the stuff he's gonna do. He carved out a hole. And later we're gonna call this is called a washer method. But a washer method has inner radius and outer radius. So the outside the radius is outside the edge of the thing. And there was inside radius. Inside radius is whatever he carved out. So he started carving the hole right in the middle. And then he can, keep on going further and further. This is really cool. And that's one thing I think traditional school should be offer class like this. This is a very cool class. It's woodworking class. When I was in high school, they actually had woodworking class, and they have mechanics stuff. Now they just force everybody to take calculus, which is stupid. They really need to put some kids that don't know how to do calculus into this type of class. They actually will be a great carpenter. They actually will be doing great things. So this is one of the things I'm actually agree with the Republicans is because they are right about the situation. We just put people into all the classes that is very scientific, but they should have classes like tech trade, like trading, like welding, like carpenter, like electricians, because fundamentally this type of job you're gonna graduate the school, you're gonna get more money than the things. So yeah, so this is really, really, really cool video. I really think about the things like this is really cool. Another thing is this is X perspective, axis rotation. So there's X perspective. Can you think about another thing that's Y perspective?
Tornado.
Good. Ceramic, tornadoes. Yes, a Y perspective. Anybody is taking ceramic in this class?
I've done some ceramics before, and it's like this.
It should be a very relaxing class, right? It's pretty cool class. But sometimes it could be frustrating. Sometimes I just smash the into the like every time you screw up, you're just like, damn it. And you try to break the thing. So anyway, so ceramic is Y perspective, woodworking is X perspective, and we're gonna talk about those X and Y perspective. That's why I introduced Y perspective for the last time. So we're going to talk about those questions here. Okay.
Are we just learning X and Y rotation, or are we gonna have to learn some other made-up invisible?
Well, the thing is, I'm not that smart. Like I claimed before, I'm not a smart person, so I don't know how to do diagonal. But RJ,
No.
you be the first one to invent it, and that'll be great. That'll be great. Okay, so in order to find the volume of football, in order to find the volume of basketball, is pretty easy. It's 4/3 pi RQ, and that's pretty easy. There's formula for it, but there is no formula for a volume of football. If you try to think about it, how do I find the volume of football? Well, depends on if you're a New England Patriot or not.
Well,
The volume is slightly smaller.
Mr. Yang,
The volume is slightly smaller if you're a Patriot fan.
if you live outside the United States, the volume of the football is 4/3 pi r.
That's true. All right. So if you're a New England Patriot, then your volume probably slightly smaller. It has some deviation on it. I don't know if you guys follow football. You should know what I'm talking about. So the next thing is what we're gonna do is we're gonna give you some type of formula for that. So we're gonna start with a circular. So do you guys know how to find the area of this? Right? It's a circle. Great, good job. So area is equal to pi r squared. And then we're gonna show you a second shape. The second shape is there is a circle here. I love they can make a circle for myself. And there is an inner circle here. And we say, hey, I want to find the area of this
Of the ring.
the ring. Yeah, exactly. So this is a very standard geometry problem.
It's big circle minus little
Samuel,
circle. Mr. Yay.
shut the hell up.
Are you happy now?
I am very happy.
Spoilers, jeez. Come on. I don't think there's everything right.
Okay, so we want to find this area shaded region. Now we have obviously we have a bigger radius outside. The big radius is gonna be like, let's just say like this. That's a big radius, and that's a small radius is like this. We're gonna call it r. So how do I find the area of this? So the area of this is there was two things that misconception like that people get confused about. They doubt people who are bad at geometry. They doubt it was r minus r squared pi like difference between r subtract each other, but this is actually wrong. This is actually wrong. Now, what is the correct way? So this is the wrong way. This is bad. This is bad at math. Bad. Something I would do. Okay. So then you go to say what is good? The good is gonna be area equal to r squared minus r squared, and then times pi. So pi r squared. The difference of bigger radius minus small radius squared. Now, why that is? Think about if I have big radius is 5 and small radius is 3, right? If I do that, if I do 5 minus 3 squared, that's gonna give you a 2 square. 2 square is going to be 4 pi. But 4 pi, and then let's compare the big one. Let's compare the r squared and small r squared. And it's going to be 25 minus 25 minus 9, so it'll be 16 pi. But 16 pi is correct because this is outer rim right here. Now, if you look at this one, it's going to give you a little bit smaller area than this, actually. Smaller than the inner circle, so it's actually bad. So this one is actually bad, so don't worry about this one. The correct way is to think about this. So this is geometry. How do we build from geometry to there? So then you say, okay, let's take this. Let's build something called, let's introduce today. Today is called a disk versus washer method. So this method, okay, disk method is going to be pi r squared. So pi between a to b, a big Rx, and dx square. Don't forget about the square. You look at this is just something like pi r squared. Next one here, between a to b of r squared, I can do in function of y, because what if my radius is in terms of dy? And that's okay too, and that can be done that way. So, with that being said, we knew what the disk method, because we are basically sum up all the disk. Sum up all the disk. So if you think about a woodwork shop, like if I slice everything there, if I slice every vertically of a cylinder, I'm gonna form a disk, a small disk, and just add up all the disk and then get the volume of cylinder. Does that make sense? Like just say if you have a piece of cylinder this way, if I cut slice like this, I'm gonna get each slice, I'm gonna get a disk. So like this, if I have this, if I cut up like this, each thing, if this is solid, if this is a ham, then each slice I'm going to cut is going to be a disc. Does that make sense? Now, what happened if I have a cup like this, right? What happened each slice?
It gets small.
No, what's the shape of each slice? It's a washer, right? And there's an orange part in it, and there's a ring outside with the aluminum. Is that okay? If I cut it this way, if I take a knife strong enough to cut this way, it's gonna form a ring. Does that everybody make sense or no? Yes, maybe? Yes? Okay. So now what I'm gonna do is we're gonna go in to look at that. So we're gonna erase this part because this part is not important. Now we're gonna talk about washer. So washer is gonna be pi of r square of x minus r square of x dx between a to b. Don't forget about the boundary. And also between a to b here is going to be big R of x, of R of y. So it can be y perspective too. So square minus R square of y dy. Now what's the cool thing is I know like one student, a lot of people like find it is very interesting is Ethan Miser. Ethan Miser is in my 7th period, and Ethan Miser actually think of this formula when I haven't teach yet. He didn't look up textbook. He said, well, volume of shapes of volume 3-dimension rotated around x-axis should be look like this. So he thought of it before I even teach it. He didn't look it up. He doesn't like look up stuff. He wanted me look up things for him, but he's actually a very, very bright individual. And he actually come up with this equation. And I say it's wrong because I kind of just want to like make him piss off. But he got upset at me. He's like, a month later, he's like, Mr. Ye, you told the exact same thing as I showed you a month ago. I said, yeah, I did on purpose. Because I don't want you to look so smart. It made me feel bad. So what I did is I create all the fail try throughout my 7-year teaching calculus, and I come up with 7 things here. And those 7 things I want you to write down. This is the most difficult part of the lesson, and we're gonna write down a lot of stuff. It's a whole page of notes, and it's worth 7 steps. But the actual step, the actual work, if you do a problem, is actually 3 lines. But the 7th step is gonna be kind of confusing. So we're gonna start with the first step. The first step is we're gonna write in red. So we're gonna say draw the graph. Draw the graph that assigned by the problem, right? Assigned by the problem.
Wait,
Steps forward.
what are we?
Okay, give me a second. What are those steps for? Is to find the volume of disk and washer method. So to find volume using disk and washer method. Okay. Okay, to find the volume. So draw the graph assigned by the problem. Now, this is not the most important part. The most important part is going to be red here. Draw the axis of rotation. Axis of rotation. Okay, draw the axis of rotation. If you don't draw the axis of rotation, everything's going to go down. So make sure you draw the axis of rotation. It's like so important. It's like the woodworking is that the x-axis that's rotating, they put a cross mark and they stick the drill inside and they rotate that thing. And that's the thing that's rotating. And that's called axis rotation. Now, for ceramic, it's a Y perspective. That Y perspective, the middle of the turning table, is also very, very important as well. So draw the axis rotation. Second step is also important. Draw a line or lines from, make sure from, underline the from, axis of rotation. So it has to have a certain order. You have to draw from axis of rotation to the boundary. Axis rotation to the boundary or boundaries. So draw from the axis rotation to the boundary or boundaries. So it could be 1 bound or 2 bounds. So I will say if you draw one bound, then you're gonna have a line. So a line that represents is a disk method. If you got two lines, that means a washer method. And you're more welcome to don't write the stuff down and just take a picture at the end, or you're more welcome to write down stuff because it kind of help you. So it doesn't matter to me. I will, you can go back to watch a video, but make sure when you do the problem, have those 7 steps on the side. I have a lot of people like Daniela in 7th period. She's like, I don't know how to do this. I'm like, did you follow the steps? She's like, no. I said, did you copy down the notes? She said, yeah, but did you look at it? No. So there's no point. So make sure you use it because this is all my 7-year worth of failed trying, teaching, and all the failed experiment gone down to the 7 concise step to help you find the value of any cool shapes. Okay, so the third step is if it's a line, it's going to be a disk. If it's 2 lines, it's going to be a washer. The third step is to decide dx or dy. How do you decide that? When you draw a line that is perpendicular to x-axis, so if something is perpendicular to x-axis, so perpendicular to x-axis, that is actually a dx. Okay, dx. So for example, like this, oops, my bad. If you draw a line here like this, the way you calculate it, this is perpendicular to x-axis, that's called dx. This is dx. This is going to be dy, sorry. This is going to be dy. So perpendicular to y-axis. So again, I'm just going to copy this. I'm going to copy and I'm going to paste. And if I just change that to y because I'm lazy, y and dy. Okay, so they can be perpendicular to the x-axis, dx, perpendicular to y-axis, dy. So if it's dx, you need to change in terms of x. So change to in term of x. And this is going to change in terms of y. So that means your function is going to change it in terms of x or in terms of y. So that way your input and output is correctly arranged. The fourth step. Once you decide this and dx and dy, the next step is decide the boundaries. So it could be x bound, it could be y bound. And a lot of time you have to find intersections between 2 points. Okay, so x bound and y bound, we're going to talk about that more. The fifth step is going to be interesting. Don't forget following thing. Don't forget pi outside the integral. Pi is outside the integral. Don't forget the boundaries. So you have to have a boundary when we're doing value. Don't forget the parentheses. That's your best friend. So parentheses. No, I spelled it completely wrong. It's parentheses. Don't forget about parentheses and dx, dy. Dx or dy. Okay, don't forget about those things. Okay, don't forget about pi, don't forget about boundary, don't forget about parentheses, don't forget about dx or dy. Those are all crucial here. The sixth step is decide. If it's a disk, then you decide either Rx or R of Y. If it's a washer, you're going to decide with Rx and R of X, R of Y, R of Y here. So there was actually, I'm going to call this outer. This is actually inner. Sorry, my handwriting is getting really bad. So outer radius and there's an inner radius. 7th step. We're almost done. This is the last step. This is a confusing thing. Sometimes you have to understand this. Function in term of x. TERM of x. That means the functions is equal to distance from x-axis to the functions. And I'm going to copy this because I'm lazy.
And switching one.
Yes. And I'm paste the image here. I'm going to just switch this to erase this x, this x, this x, this x. And I'm going to switch to y, no, x, x, y, y. So the function in term y, that means the function is equal distance from the y-axis to the function. This is actually kind of important to help you solve the problem. Now we did all the hard part. So you're more welcome to take a picture if you want. Let me stand up like this. Maybe like this. You're just gonna take a picture of this and at least you follow those few steps. And you're more welcome to do that, or I can post on Emoto. It doesn't matter. But those are the 7 steps that you have to consistently doing over and over. Now you can take a picture of your handwriting because it's much better than mine. Like Gabby's handwriting is very better than mine. Samuel is definitely more ugly than mine.
Yes.
Yeah.
My mother claims I write in an entirely separate language.
Okay, so we're gonna do a problem.
But the good thing about handwriting means I can read yours, so benefits.
That's true. Y equal to square root x. We're gonna calculate the volume of football, and the best shape I can come up with, so I call this a quarter football graph. I call it either quarter football graph or a eyebrow graph. So I'm gonna graph this, and I'm gonna tell you to rotate around x-axis or y-axis. They are totally different things. So each one is 2 units. Each one is this like this. Each one is 2 spaces is 1 unit. So this one is going to be like this. So we're going to find the volume of football. So this one is the first one. The second one is going to be blue line. So it'd be x equal to 4. So x equal to 4 is going to create this boundary here. And then the black boundary is going to tell you says y equal to 0 or x-axis. This could be says x-axis. And we're going to say rotating. We are rotating around x-axis. So this is what working place is rotating around x-axis. So basically you have this shape and it's rotate inside the board and outside the board. And when you rotate inside the board and outside the board, it's gonna form like a pretty much like a football or bullet shape. Can you guys see that? Football or bullets. So, and if you guys cannot see that, I'm gonna show you on Desmos. Because if I show you on Desmo, this is a cool part of somebody actually designed this to help people visualizing. I already did that. Been there, done that. I did that with my son, and he likes it. So solid revolution. So you see this. Start with this part here. This is the inside shaded region. So if I shade that part I just give it to you, it's going to look like the blue part. Now, if I rotate, it's going to form like this. Do you see that rotation around x-axis? Do you see that rotating?
Yes.
If I want to zoom in a little bit, maybe it helps you. It's rotating. The person who invented this is pretty cool. Like they can see the rotation. Do you guys see it?
Yes.
Do you see that football shape? Like half a football, sorry. Not a full football, but half a ball. But you can double it to get a full football. Does that make sense? Okay. So what we're going to do is we're going to rotate that. So we're going to follow all 7 steps. It's not as scary as this look like. It's the 7th step is pretty easy. We already finished the first step. We did not draw the axis rotation. So how do I draw the axis rotation mark? That's going to look like something like this. So that means I'm rotating around there, and you have to draw that. If you don't draw that, you don't know where to start. Make sure you draw that. So that's axis rotation. Now within the boundary, you're going to draw a line or lines. So you draw from where? What did I say?
What?
What did I say? From where?
To the boundary or boundaries.
So from the axis rotation. From the axis rotation. You cannot start from the boundary to the axis rotation. It has to be axis rotation to the boundary, because that's going to tell you how far that distance, the radius is. So this one is going to be here, and I'm going to draw it here. Now I'm going to shade this region. This is a region I'm interested in. So that way some people says, you know, this is actually a good thing if I shade it. So I'm going to, oops, my bad. Don't use white, use blue. So this region that I want to rotate like this. And then now I'm going to draw it from the axis rotation. Remember, where's the axis rotation? Axis rotation is this line, right? Does that make sense? You draw it from here and going here. Do you see one line or 2 line? One. There was no second boundary. If you see there's no another boundary after that, there's nothing there. So there's only one boundary. Is one boundary means disc or washer?
Disc.
Disc. Good. So that we're gonna start with, this is a disc method. So disc. So we're not gonna say method, we're just saying disc. Check. This is the 3rd step already. You already finished 3 steps out. You're already halfway there. Is this dx or dy? Dx. Look at the line, it's perpendicular to x-axis. So it's actually dx. So that means each slice. So basically they start adding the slice from here. And each slice is going to be formed like a disc. Because this is rotating around this, it's going to form a disc. It looks like this. So basically adding from a small disc to the big disc. So each disc, the infinite amount of discs is going to add together. So that's going to be a dx. Dx is mapping function in terms of x. They already did that. Y equal to square root of x. Done. And then we're going to go in further. What is the next step after we decide dx? Decide a boundary. So the dx is integrate from what bound to what bound? Remember, I just show you from what bound to what bound.
0 to 2.
No. 0 to 4. Thank you. This is a 4. Okay, so that's going to be 0 to 4. So you're going to say 0 to 4. Wow, we are almost done. We are almost done. So we are at a I think 4th or 5th step, 4 steps right now. So, shh. Okay, so here I'm gonna go with, don't forget certain things. Well, pi, don't forget. Integral, don't forget. The boundary is 0 to 4, don't forget. Now we have to decide are they dx or dy? This is dx. Now we just have to decide, is this disc or washer? If it's disc, then that means this part is gonna be r of x. Remember r of x, look at step 7. The r of x is represented by the function, which is square root of x. Because square root of x is going to tell you how high. For example, I have height of 1. For here, I have height of 2. But it's basically I will plug in. If I plug in 4, I'm going to have the height. So the height is throughout constantly changing from 0 to 4. So you are integrating between 0 to 4. I'm sorry, not 4, but this is x. And then so the r of x here is equal to square root of x. So that's equal to square. So that is my final work. This is the setup. If you set up, you're going to get majority of the credit. So let's say if this worth 10 points, you're gonna get 8 points out from here. But you didn't need to have all the elements, pies, boundaries, squares, parentheses, dx. You need to have all the elements here to get all 8 points. Evaluation, just only one step. Evaluation is simple, but if you don't know how to evaluate square root x squared, it's going to be like this, 0 to 4 pi dx. And that's going to be x squared over 2 between 4 to 0 pi. And that's equal to pi times 8. So it's 8 pi minus 0. So it's 8 pi. So the answer is 8 pi. Now, do you guys still remember the first image when I turned on the iPad? What's the first thing you guys saw? Do you like, after 2-hour lesson, I don't know anything what happened this morning.
Mr. Ye and derivative of Mr. Ye.
What is the first image you saw when people walk in? Ah, you're right. That was really good. That was really good. Who says a bun cake? You saw Among Us? Okay.
It's the first thing we learned on the page.
Yeah. Among Us.
Okay, so we have the same shape. We have the same shape. And this time, we are rotating around y-axis. I want you guys think about what kind of shape would that look like. I'm going to draw the axis rotation, so I'm doing first step for you. And then you guys going to go figure out what will be the second step is going to be. And you have to make sure you understand what this shape look like. What does this shape look like? It's really hard to describe, so think about it's rotating on y-axis. I have this things here, it's rotating around y-axis. So, Samuel, shut up. The reason when you stop talking and other people stop thinking, they start think, Samuel, Jesus, you're annoying. Can you shut up? And that's in their head. So you need to stop because I will ask you a question when the time's in. So I hear it's rotating around y-axis, but can you visualize the shape?
How do you know it's rotating around?
I will tell you. I will tell you. Good question. The question is gonna be like this: y equal to square root x, x equal to 4, y equal to 0, and they will say rotating about y-axis. But first of all, can you see that shape? If I take this, rotate around y-axis, what kind of shape am I forming? I know this is very challenging for a lot of you guys because, yes, it does look like a bun cake. Do you guys see that?
Like if it wraps around the y-axis, then it looks like a little mountain.
Yeah. And this is the middle part of the bun cake. This when you carve out, it's gonna be like this. And that's the shape of what you want to find. Now, I want you to go in through 6 steps. And how much time I have?
You have about 20 minutes.
Oh, good. We have a lot of time to practice this. So we'll ask you to go do all 7 steps.
Yeah, I know. Okay, but if you rotate it around the little bubble,
No, we've
Like-
got 30 more minutes.
Okay.
like the x-axis was before. Okay.
It's rotating around y-axis. It's like this.
It's like okay,
Like a ceiling,
it's like
like
a
a,
dick.
you're on a ceiling fan.
and it's like this thing, and it rotates.
Wow, that was really good. Thank you, Happy.
Yeah.
Thank you, Mr. Ye. You finally managed
No,
to make me find
Now I think you could bring in buckets.
Huh?
It's a largest happened.
It's not half a donuts, no. To calculate the volume of donuts is actually quite difficult. There was actually a Papa's torus theorem is to find the volume of donuts. Donuts is a little bit different. Donuts is a little bit harder than this actually, but this is a bun cake.
It's volume of 0.
The reason why it's not donuts because this one actually doesn't see from the top view. If you look at it from top view, you don't see a hole because it's all completely sealed. There's only maybe one small dot of hole that's going to. Actually, you don't have any hole at all actually, but you're gonna see the dip
I mean,
like a bun cake.
would it be like a dot of infinitely small size or something.
It's a very, very small, but you can barely see it. I mean, probably like more likely you don't see it. It depends on how infinite the machine can make the shapes. It's really hard to see. Now, the cool thing is this does not have a donut. It's actually look more like, I have no idea. Bun cake is probably the best analogy. Let me show you the shape of bun cake. And if you guys want to bring cake, yesterday's second period, I should bring a bun cake. She loved to bake. She brought a cake over. She shared with everybody.
Well, yeah, extra credit. I think she should just make a second one for us.
Nah,
Was it
not for you.
margarita?
Huh?
Was it margarita?
It was long.
No, it's lower.
It's sort of like a really wide funnel, I guess, Mr. Yang.
So bun, how to spell bun cake, Lewis?
So it's already there. Bunny die math.
So it looks like that. So that you see the things inside, it's gonna be looking like that.
That looks so scrumptious.
What does that mean? Does that mean it's delicious?
Yeah. Mr. Yang, if I bring pretzels.
Don't use big word on me, Abby.
Mr. Yang, if I bring soft pretzels.
What's busted?
If I bring soft
Mr. Yang, when you say shit slaps.
What?
If it slaps, it's good.
No.
Slap.
Yeah, it's flat.
Yeah, it's flat.
It's flat.
One cake.
Okay, like drip to describe a clothing.
If you say a cake is dripping, there's a lot of problems.
A cake is dripping. Yeah.
That bun cake kind of dripping though.
Okay, so that's rotate around y-axis. Let's try it. Let's try it. So it's analyzes disk washer, analyzes dxdy. Try it. The problem is not about you right or wrong. It's about what do you learn from it. It's actually a really, really great quote by this guy. Honestly, I don't think his teachings are all that. To be honest, because he's super bright. But I think that quote is worth more than anything.
Hold on, I'm not ready.
So do you think this is a disk washer, dx dy, and where the boundary, and what the thing is, and that this is an entirely different problem. So
It's still a disc, isn't it?
I have no idea. I'm not telling you. Okay, you have 50-50 choices. So make sure you draw the axis rotation. I already did that for you. And I'll give you like 3 minutes head start. And now I'll see. We got 30 minutes. We can count through a lot of problems.
I say it's a disc.
Are we gonna go full on for all three?
So I'm gonna proceed.
Yes.
as a disc.
Flip it for him.
I'm going to stretch your brain so much, you're going to lose all the brain cell. What?
I'm not either.
Why?
I'm so sorry. So,
Kansas City is kind of boring though, honestly. Like if you're doing like Las Vegas would be more
Wait,
fun. Why don't they
Kansas-
hold a
Kansas-
tournament in
Kansas
Las
City,
Vegas? Do they have volleyball tournament in Las Vegas? That'd be
Yes.
more fun.
Yeah,
Oh yeah, that's fun. No, like Kansas City is the middle of nothing. That's true.
yes. Series that failed.
Actually, I have seen like I never seen like I see a melting snow before, and I see like a flake before, but I never see actually snowing.
It's not worth it.
I never see snowing. I see everything else. So I went to New Hampshire, I saw snow on the ground is melting, or Georgia or whatever. And I went to Denver, there was like actually snowflake, but I never go to ski. I really want to take my family to go ski, but I'm not rich enough.
Well, do you know what it is?
Mr. Yeah, you don't need like a fancy ski lodge. You need a car. You need to find someone who left skis somewhere, and you can buy. And with the ski lift, usually people just like cut lines and
Cut out
like-
cardboard strips and put them on the bottom.
Yeah.
So this is one line, but how, like, where does one line come from?
You have to draw from axis rotation and see in which boundary you see. So for example, this one, I'm gonna give it to you. This one is actually a washer. So I'm gonna show you why it's a washer, right? So you think about it, right? Pay attention. Why is it a washer? Well, first of all, we draw the axis rotation. We already did the first step. The second step is we draw the axis rotation. How do I draw it? This is the axis rotation. This is where we base off from. Okay, we're gonna draw from there to the boundaries, right? So because we're rotating this way, so it has to be this way. So the first boundary I'm gonna make is this red line here.
What?
The first boundary I'm gonna see is the first red line. It's gonna be right here, because that was the one the bound. But I draw from the axis rotation to the boundary. Now the second line I'm gonna draw is I'm gonna draw a purple line. The purple line's going from the axis rotation all the way to the second boundary. Did you see that second boundary?
Oh.
Remember that woodworking things? There was an inner radius and outer radius. The purple line represents the outer radius. The red line represents the inner radius. And then you go in from here, you say, oh, okay, this is an example of washer method. This is a washer method because there was two radius, because you want to take the bundt cake, you want to take the middle part out. That's why you have a container built that way. And then when you do that way, you can actually take it out. So this is actually a washer, not a desk.
Wait, but I thought the boundary was 0 to 4.
I just don't understand.
Yeah, it's a 0 to 4. It's from here to here.
The boundary is 0 to 4, but there's another line that you have to cross to get to that one.
That didn't make any sense.
Okay, so what he's trying to say is this. There were two boundaries. Just think about, you have a skewer, right? You're gonna touch this first part of bundt cake. Right? And you're gonna touch the end part of the bundt cake. So let's just say if you want to measure the thickness of this bundt cake, you want to say, okay, what is here and what is all the way here? So it's the first time you say, if you take a skewer from axis rotation, the first time you touch a bundt cake is the first boundary. Second one is the outer rim. Okay, so now what happened is, if you do here, is this dx or dy?
This is dy.
This is a dy, thank you. So this is a dy here because this is a perpendicular to y-axis. Think about, it's always perpendicular, so it's perpendicular to y-axis. So now this is rotation. Am I losing anybody? There's a washer. This is a dy. Am I okay? Am I okay? And then I'm gonna go to the next part. I have to, if it's dy, you want to write in terms of this. So you have to write x equal to square root y. Does that make sense? You have to write f of y is square root of y. So that's the things that you want to think about. So that's going to go there. You have to write a function in terms of y. So solve for x. Now here's the next hard part. What is the boundary here? If I have a horizontal slice, yes. X, wait, x y squared, thank you.
You have to set it
Y squared.
Y's.
Good catch. Okay, so what is the next thing? Is where the boundary is going to be.
Is it 1 to 4?
It's not 1 to 4.
Is it 0 to 2?
Is it 0 to 2? Yes. This is 0 to 2. So this y is 2. This is 2 here. Is it 0 to 2? The reason being is your slice is like this. And you're going to stop exactly when this x or y is equal to 2. You're not going to go further than that because you cannot take the integral more further than that. So that's going to be 0 to 2. So 0 to 2. And how do I know it's 2? Well, we're going to look at a function y equal to square root x. We're going to say when x equal to 4, so y equal to square root of 4, that's equal to 2. So between 0 to 2 in terms of y value. So the bound is a y bound. It's not an x bound. So now what is the inner radius and what's outer radius here? What is the r of y here? And what is r of y here?
R of y is y squared.
Shh, I want to ask other people. What is r of y here? The outer radius. Is what? 4 is good. Because that is the distance. It's always 4. It didn't matter where I measure, it's always 4. That's always how wide is my bun cake is. Well, the 4 is a radius, not diameter. Because you measure the cake, it's actually measured by diameter. So diameter is going to be 8, but this radius is always 4. Like you measure tire sizes, so you go into diameters. You don't measure radius. Or TV size, you measure diagonals as well. So that's actually pretty interesting. Okay, so what is small r of y? Y squared. Good. Because y squared is given by y axis to the function. Now that's very important because later on it's going to put a big difference. So that's y squared. So let's put everything together. Pi. Don't forget that. 0 to 2. Don't forget that. The outer square minus the inner square. And matter of fact, I'm going to do red. And then you got to make sure it's dy. And on your homework, what you're going to do is you're going to go use a calculator to do it. It doesn't matter you use X or Y. Just type in because the homework, it gives you answers.
Wait, why'd you square?
Because I got to square the
That's the washer method. You gotta square it because of the circle.
Yeah, but I think she's talking about why is this y squared. The reason being is I will solve for x here. So I square both sides. So that's going to be x equal to y squared because I want to do it in terms of y because the dy is giving.
No, I don't understand the 4 squared minus y squared.
Okay, that is the washer method. So the washer method says, right here is the outer square minus inside square. Outer square minus inside square. We're actually using this one because of ry.
And it's just a shortcut to subtracting the volume of the empty circle to the actual circle.
Okay, so then that's my final answer. You can use your calculator. Learn how to use your calculator. They're going to give you a decimal. The decimal need to make sure you do a pi in the front. So that way you can do it right. So you're going to, when you do calculator, you can try it. And they'll give you an answer for that.
Like for a calculator, is there a way we can use y or can we just use x?
Just use x because that's just a variable. It doesn't matter they are data or x or y. But if when you write it down, it has to be in terms of dy. But TI Inspire, you can do y and dy. But on TI 84, they only stick with the x. So just use x just in general because one perspective is fine. As long as you do the inside, outside, boundary, and pi correctly, then you should be fine. How long are you going to be in Kansas?
My Saturday, Sunday, Monday.
I come back Tuesday.
Oh. Well, it depends on if it's any class period, you can zoom in to the things because like I think Paige is absent. She been zoom in for the things. I don't know if you want to see me on Kansas, but in case if you want to see me, if you want to listen to the class, then you can still tune in.
So we're gonna do lecture.
Huh? Well, tomorrow is actually we let people try it, try the problem. Now, if you have problem, then we can find a way to see if we can zoom with other students here. And if you like, say, work on a problem in Kansas,
Yeah, I probably have some time.
yeah.
Never mind.
What'd you say? What are you gonna say?
Well, Kansas City is not in Kansas.
It's in Missouri.
Oh, okay. I didn't know. No, now I sound like total stupid.
No, it's just people from Missouri or from some other countries.
Oh.
They're the idiots.
I can say this as someone from Missouri.
What? Why would you name it after
Exactly.
So what?
The worst.
Well, I think most American though, like Panama City is in Panama too.
Yeah, there's a Panama City.
No, they think it's something else. Oh, they think about a country.
It's that different.
They think country is in the Panama. That's what the problem is.
New Mexico's not in Mexico, you know?
I don't know. Whatever. I sound pretty stupid most of the time. Anyway, it doesn't. I already claimed that I myself stupid, so it doesn't really matter. He just happened to have a stupid teacher, so I don't really care.
Yeah, I think it's worth to share with the class.
No.
Okay, so we're gonna do the next shape. We're gonna go with square root x still. Now the way that I draw boundary is a little bit different. So this one's a slight change. So think about what kind of shape you're gonna form. It's still y equals square root x. Now this time is a little bit different. This time it's gonna be x is equal to 0. And y is equal to 3. And it's rotating around y-axis. Okay, rotating around y-axis. So it's rotating around y-axis this time. Now, first of all, let's draw it. Let's practicing drawing, and let's practicing drawing an axis rotation. And let's think about shape before we even do the problem. You're always the first one to say it. Let other people have some opportunity. You can text me. How about? But, huh? It's not the same shape. It's the same equation, but the boundary kind of switch. So it's a totally different shapes. And this one has something to do with a movie. Or it could be some toy that you play, especially boy.
Could it be one of those?
One of those what? Say it.
Those little swing things?
Oh no, that's a Chinese yo-yo. No. No.
I got one of those for Christmas.
Really? Chinese yo-yo? That's pretty cool to play though.
It's like a little hourglass, and then there's like a string, and you like.
Yeah, we'll probably know how to play.
Oh.
Yeah. It's
I've already-
Chinese yo-yo. I think that's what they call it, Chinese yo-yo.
Those are cool.
You can actually throw it up
Yeah,
and can catch it.
I've seen people do cool things
It's
before.
weird.
And they can catch it behind the hand, behind the back, and stuff like that. Just tell Will to bring it one day, show it off.
It's got a string
What's the
and
thing?
it's like
I don't have to be-
cut.
So no, I think the balance is balance.
So it's like a
If you rotate so fast, it will balance itself.
It's
If you're slow, then it's not gonna balance. But if you rotate fast, it will
but it's
balance.
spinning really fast.
It's actually pretty interesting.
It's also how you stay upright on a bicycle because you're going fast.
Okay, come on. Let's think about the shape of here. Think about it's a disc washer. Think about what kind of shape, and think about a graph. I will say this is something that you guys, especially boys, play a lot.
Like
When you're about third grade. No.
Beyblade.
What'd you say?
Beyblade.
no way.
That's right. I played with
What's a
Beyblade.
Beyblade?
You know what a Beyblade is?
Okay.
It's like a ring. It's
Oh,
like,
it's rubber.
So it's
Yeah, it's
That's what I said.
so it's like Fox, except for they're made of metal and they give you something.
You
to
spin
watch.
it off.
It's really stupid. They're made
Yeah.
of plastic.
But why?
That is dumb.
now you can't injure these.
Exactly. That's what I'm saying.
you can't hit somebody in the eyes anymore.
But they made like the rubber wheel ones out and like shut them at each other.
No, it's just the top.
No, I will tell you like the engineer of Beyblade is pretty amazing because at first they are like a metal, right? But then they come out with new things. So
Each other and then like conversation.
So my son is into the Beyblade at different age than you are. Now the new Beyblade was actually pretty cool. So there's one Beyblade, I thought the engineer is super awesome. So that you're supposed to fight each other with a Beyblade, right? But there's one Beyblade that you can hand spin it. And then you can burst of somebody that uses the pulling string to fight each other. And it's actually on YouTube and I saw it's pretty cool. So what happened to the hand spin is a back spin. and then the side is rubber, so they kind of absorb the other Beyblade's energy and make them spin. And they will actually, the other one was actually spin faster and faster and faster, and this one, the metal one, was actually spin slower and slower and slower at the end.
Yeah,
And so actually it's pretty cool. As I thought it was like, how did the people come up with these things? Like they show it in cartoon. It was like,
El Drago.
Yeah,
Huh?
we should watch
El
the
Drago
Beyblade
top.
anime.
It's like
it's a left hand.
It's 3 dragons. They're pointed to the left. You spin it. And it has like little rubber on the side of the dragon, so it can do that.
Yeah,
Like-
but what's that character? The character's name's Free, I think.
Oh, I have no idea. I just
F- Yeah, so I was watching. I was like, oh wow, cool. That's a cool idea. And I didn't know they actually have one of those. And I tried. It's actually pretty cool.
We should
They just absorb the energy from the other one and eventually just overtake the other
those,
energy.
like rubber wristbands. If you use any type of frame, and you just like you have a small one of those, you can put it on it and spin it, and it'll do the exact same thing.
That was the best. I don't know. There's so many things.
Everyone's talking about how Beyblades act like Flash.
Cool math game. Cool math game. I love cool math game. They have a tank game. It's fun.
Oh, yeah.
The tank game is awesome.
The cool
Except now I didn't even have cool math games. I had the Chinese version.
Oh, that's damn.
Well,
The best version.
all the games are stolen from other game sites.
We're very good at stealing other people's.
Yeah, regular cool math games is the Flash game. You would get like $1 DVDs.
Yeah, but nobody watch DVD anymore, so everybody's streaming now. Okay, so let's calculate this.
Yeah. Calculators. What? Oh boy. Yep, calculating that sure is something. Good for you.
It's just like the same shape, but it's like from 0 to 3.
So it's gonna be like this kind of shape.
Well, it's a tornado.
I was thinking of it before.
Because the boundary is different, the shape's gonna create a bit difference. How much time we have?
4 minutes.
Yeah, we've got 4 minutes.
You got 4 minutes to do this. Come on. Try it.
Beyblade, Beyblade.
Yeah. No.
It's like this.
No, no,
it's like
opposites. It's a reverse.
It's the same shape, but it's just
Well, it's just a
on the
different.
y-axis.
Yeah, it has to have.
Could you just draw it?
No, you're gonna practice drawing.
Is it the same shape?
No, try it first. It's okay to be wrong. It's just learn something from it.
I think
That's too much.
One's a 1-1,
I think
and then
1-1,
this
4-2,
and then 9-3.
9-3. Thank you.
4, 5, 6.
We'll just get it after.
Dude,
from X equals 30 to Y. Yeah, that's what the boundary was too. I was like, what?
yeah.
Okay, so it's like one of those stupid tables.
Because it's this
I think-
part.
I think
We're
this
talking about this
Have
part.
like flat
That's
at
what.
the bottom
I
of
don't-
the sound,
It's like-
and then
think about it
the
like
y
this,
equals
but
3 is like the tabletop.
Like this area is the
Copy.
is this thing. but-
Spin top. It's also another movie is based on that too. I don't know if you guys seen what's that movie? Leonardo DiCaprio. That they get into dream of a dream of a dream.
It's Inception.
Inception. There you go. It was about a spin top. Yeah, the spin top.
That gives us the really dumb ending.
Yeah, and like ending, I'm like, so it's still in the dream, or not in the dream?
I don't know. I mean, the top looks like it's starting to wobble just before it cuts out, but we don't know.
Is this right?
Yeah.
And then it just.
Spin it. Yeah, draw the axis rotation.
It's a
Mr. Yeah, you like have to put like 1/2 because it only has to do like it's good, but it's like covered both sides of the axis. Like it's been like half.
No, you don't have to cover 1/2 because when they rotate, it's a full circle.
Oh,
Every time it rotates, it's full circle, so it's gonna be.
oh yeah, because it's been a fantastic thing.
RJ, instead of measuring what's below, now you're measuring
Yeah,
what's
no,
above.
I don't understand why. I understand that.
Alright, so
You know
like,
what
take
it's
this
like?
bump, you got the bump kick, right? Now put a Beyblade in the middle of it. Now you got a full circle.
Yeah.
Yeah, exactly.
What indicates that we're taking?
Oh yeah, how were we supposed to know?
How do we know we're finding the Beyblade part and not the butt kick part?
Well, it depends on the boundary, right? So the boundary says this. So if you have understanding what a boundary is, because the boundary is a little bit different than last time, is this one is here is you say it's 0, 0, 1, 1, 2, 4, and maybe 9. So it's gonna be 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's gonna be here.
Like the bunch.
So it's gonna be 3.
Why was that not just a bigger butt kick?
No, because like the boundaries here are y equals 3 and x equals 0, and so they're going to make the two
X
sides
equal to
of the
0.
Beyblade, and then the line is going to make the third side of your Beyblade, so it's going to be this part. Because when we make
So
the
if the boundaries
boundary,
in X, you base it off the perpendicular of the X axis.
Yeah.
The boundaries in Y, you base off the perpendicular.
when we were making
No, depends on what it is. 3 things given to you. So you're gonna create whatever's inside.
If it said X equals 9, would you be finding the butt kick part then?
yeah.
Yes.
If that x equals 9,
I clicked. Alright.
it would be a line here.
No, but x equal to 9, but also need a y equal to 0 though.
Yeah.
Yeah.
Also need a y equal to 0. So in order to do that, but we can rotate this shape around x-axis too. Then that's gonna be a new shapes. So right now we practice y direction. Now I can change the direction to x direction. Then that's completely different. So let's try this one first. Let's write it out and compare the answer with each other.
Wait, so are we finding the topper shape or the one on the bottom?
We find the spin top
We're
shape.
finding the top of the shape because the two of the lines give us like two sides of a triangle, and our third line is this weird curve thing.
Like, okay, see how the boundary is Y equals 3? Remember how the other one was X equals 4, right? And we went from the X axis to the shape. Now we're going from the Y axis to the shape. So that was not-
Mystery, this is weird.
You can form any kind of shape. Later on, we're gonna talk about cross section. That's even more interesting.
The other problem-
So-
okay, so it was X equals 4.
If I bring
From the X
pretzels to the class, will we find the area or the volume of the pretzel?
But since we're going from
I
the
don't
Y axis,
care for pretzels.
we take here, we're gonna find
Donut maybe.
because
Wait,
it's-
is it the bottom?
The like soft pretzel mystery.
is it like red wall or is it-
Hate pretzels.
You don't like hard pretzels or soft pretzels?
I hate pretzels in general.
Wow.
I like donut and green tea
Wait, what
latte.
type of donut? What type
Green
of
tea.
donut? What's your
Huh?
favorite type of donut?
What's my favorite? I like Krispy Kreme.
No, like like a classic glaze, old fashioned, chocolate covered, cold chocolate. What type of donut?
Chocolate sprinkle.
Wrong. It's apple fritter.
Ew, gross.
Both of you are wrong. The answer is yes.
Because,
Okay, so first question I'm gonna ask you rotate the y-axis, and then second question I'm gonna ask you to rotate x-axis. But we're gonna keep on extend that. Today's question, first 4 question, you gotta finish first 4. The first 4 just straight line. You're gonna see a cylinder, but if you can go further, because sometimes you need a break of 2 integrals too. So
we're so before looking at this one, but it's not extreme. It's the same thing, just not going.
Some of the bun pans are pretty fancy.
yeah, that's true.
They get insane.
We'll make a bun cake now.
Yeah, you make a bouquet tomorrow, bring it.
No.
Anybody want to bake?
Just go to Nothing But Cakes. They get really good ones. Really.
What?
Nothing But Cakes.
What is that?
Where
It's
is
by
it? Like
Vincent.
Sand Lake, I think. Like,
Um,
Wait, they make bun cake?
Yeah.
wait,
Well, it's literally
Nothing
Nothing
But
But Cake.
Nothing But
Nothing
Cakes.
But Cake.
It's got really good.
It has small ones. And
It's
big
really
ones.
Yeah, it's like
Really?
high.
It's by like.
Oh, the high end? I don't know.
No,
I
not expensive. High end is in like good quality.
okay.
That's walking distance.
It's really close.
I got you.
Cool.
Oh, you got me. Okay, cool.
Yeah, I just get past the boss.
Then you had to work.
No deal.
No go. Hey, what happened to Alex? Alex, okay?
I think he's dying. I don't know.
You had COVID?
I have no idea. I haven't seen him. I'm staying away from him. I'm not losing my last part of my senior season to him being okay.
How sick was he? You don't even know what happened.
I don't care.
What kind of brother are you?
He stays in his room, doesn't walk out. I do my stuff.
I wouldn't say go serious subtracting.
They have a tiered bunking? Yo.
Of course they do. Which ones? If you're subtracting this
How much
area
is this?
under here, or you're taking from the whole area, right? From like the length level, and then you subtract this area.